Well, we're going to talk next about the subject of interference. So interference is one of those things that happens all the time, happens inadvertently, and can really be a showstopper when you're doing design. And I'm talking about something as simple as two volumes occupying the same space. Okay, something that is so elemental. It seems like it doesn't merit a whole bunch of attention. And well, just do it right. And you won't have any interference problems. And of course, in the heat of the battle, the experience is a little bit different. So SolidWorks, in fact, does make some very powerful utilities to be able to verify your model, to check it, to ensure that you do not have these overlapping values. Okay. So our access to that is, if you go here to the Evaluate tab, here is the button for interference detection, which we see here. Now, this is interference detection with the model as it sits. Okay, so wherever you happen to be, this is a model of a U-joint. Okay, so as you can imagine, this will move in accordance to all the mates. And what interference detection will be able to tell us is where the parts are occupying the same volume, all the different parts that are having brought into the assembly. Perhaps I should have prefaced this with a couple of words about a universal joint or a U-joint. This is one of the examples from SolidWorks, and this shows the mechanism that's typically used. So when you do not need a constant velocity transfer between an input and an output shaft, when those shafts are not perfectly lined up. Okay, so you would be very likely to see this in power transmission elements, going, for instance, from a motor, to some driven component like a turbine, like a fan, or a motor going to say, for instance, the rear wheel axle of a truck. Okay, you would see that. So either low speed or when you have higher speeds, but the angles are relatively shallow. Okay, only then is it okay to use a so-called U-joint or universal joint. Okay, and you can see how that motion happens here. Of course, in the usual assembly fashion, you can really drag any component that moves and investigate its operation. Okay, in this case, this happens through so-called spider assembly here in between. Spider assembly is also known as the trunnion. Okay, and you can see it there. In fact, if I just completely hide that component, and it's a little bit easier to see. Like, let's go ahead and hide both of those. Okay, and that is the trunnion or the spider component in the assembly. Okay, let's go ahead and bring them back. And now let's just go ahead and have SolidWorks tell us if there is in fact a problem with interference. Okay, so we'll go ahead and come here to interference detection, hit the button. Okay. Selected components, you can do selective interference checks between two components that you suspect might be at risk for having had some manner of interference, or you can just select the entire assembly and have SolidWorks calculate for the entire assembly. Okay, so here we go. Okay, I have the entire assembly selected. Okay, and that would be just a matter of coming here to the design tree if you want to select something else. Okay, hit calculate, and very quickly SolidWorks will identify all the interferences that have been found. Okay, so notice that it has identified 10 interferences. Not only that, very nicely it has ranked them in decreasing order of importance. Okay, so the most important up on top, as importance defined as the volume of the interference. Okay. If we select one of those, the viewer in SolidWorks will identify where that interference actually occurs. Okay, so let's click out of here. Just take a look. This should look suspect to you. If you are in a shaded with edges view, as we are right now, shaded with edges, and you fail to see a distinct, a differentiated edge between two components, that means that those components are going through each other. Okay, because you're not able to see the actual edge of the part, that would be visible under normal circumstances. So this is kind of a telltale sign, and sure enough, when we do interference detection, it shows up right away. Okay, SolidWorks will highlight the specific area of interference there. So in this case, the shape of it is that red disk. Okay. By the way, you have some options down here that will allow you. Okay, so it's right now the one that's turned on by default, make interfering parts transparent. Okay, so that lets us see very readily what's going on. Again, just to bring the point home, if we were to make that transparent, okay, so we would see that there's an issue there with the radius of that component, versus the radius of the hole in this part. At this point, we would be able to implement our countermeasures. Perhaps we need to enlarge the hole, or in this particular case, there may be just an issue of the depth of assembly of this part here, so it looks like that should sit a little bit higher. If we look at a side view in there, it seems as if that should just sit a little bit higher than it is. Okay, so if we look at the rest of the interference detections there, we'll go ahead and select entire assembly, calculate again. So we can go down the list in here where that was interference 1. Interference 2 is identified as taking place between the spider, which is the block of the trunnion, and one of the pins of the trunnion. So if we make this part hidden here, in fact, let's go ahead and hide both yokes. In there we can see SolidWorks is highlighting for us in that purple color what components are at fault. And there we see the exact area of intersection. It looks like there are some thin tubes pointing to the possibility of an outer diameter for the pins being slightly larger than the inner diameter of the trunnion. Now, in some cases that may happen intentionally, purposefully, if there is an interference fit between two parts. Now, we'll talk about that in the context of tolerancing, and there are some parts that are in fact assembled through interference. So in a case like that, you can actually tell SolidWorks to ignore certain parts or certain instances of interference, so that they don't get in the way of finding the ones that you really might be more concerned about. And that is available elsewhere down here in the options, and we won't go into that. Just know that is available. Okay. So on down the list, let me go ahead and turn back the visibility. So where else do we have interference? Well, there's another place yet. There's interference 5, 6, 7, 8. Different places. Of course, this model was built, with multiple interferences in order to illustrate these points and the capabilities of the interference detection utility. Very well. So that's what we can do with the interference detection button or utility. In a similar manner, we can also do clearance verification. There may be instances where that's what's of interest. Okay. Others yet, hole alignment. We're not going to go over these in any detail. We've already looked at measurement, mass properties, and there are others yet, like section properties, sensor assembly visualization, and others yet that you can evaluate on your own.